Unit 3, Lesson 7, so example number 5. Given the right triangles ABC and DEF, where C and F are right angles, AC is congruent to DF, and CB is congruent to EF. Okay, so describe a precise sequence of rigid motions which would show that triangle ABC is congruent to triangle DEF. Okay, so again, depending on what you choose to do will change what your answer will look like. So first thing that I'm going to do is I'm going to reflect, and again we want to show that these two are congruent, so it doesn't matter which one I map to which one. So I'm going to move triangle ABC onto triangle DEF. So I'm going to apply a reflection over AC of triangle ABC. And so what will that leave me with? That will leave me with a triangle that looks like this. Okay, so that's after my first rigid motion, followed by, well, now my purple triangle is over here and I want it to line up on top of the DEF triangle, so I need to slide it, a translation, and I need to identify a pair of corresponding parts. So let's say that I'm going to go from B to E. Translation of BE. That's my vector. Okay, apply a reflection over AC of triangle ABC followed by a translation of BE. Since a reflection and a translation are rigid motions, triangle ABC is congruent to triangle DEF because angle measures and side lengths are preserved. So all it really asked me for was to describe a precise sequence of rigid motions which would show that those two triangles are congruent. We really only needed the top. You could have done other transformations. You could have reflected over, you could have moved DEF onto ABC. It really depends on what you see in the picture, as long as you are communicating those accurately and appropriately. So reflection, I gave you a line of reflection. Translation, I gave you a vector that starts at B and ends at E. B is the corresponding part to E. Could I have done A to D? Yes. Could I have done C to F as my vector? Yes. Or vice versa. If I'm going to move triangle DEF onto ABC, then I would reflect over DF and I would use a different vector of corresponding points to describe it. So again, it depends on what your description includes in it, as long as those two triangles end up on top of one another.